All right, good morning, biology. How's everybody doing? Hopefully, you had an outstanding weekend. We're kind of moving through a little bit in this ecology unit. We have a few more lessons to do, and then we'll get to kind of your final project and test over this unit. I'll explain a lot of that in much more detail at a later time. So let's get going into this PowerPoint. Today we're going to talk about energy flow. And when we talk about the energy, we're looking at kind of a metabolism. So when we say how does energy move through an ecosystem, we're talking about the energy that you get from eating other animals and or eating plants. How does that move through an ecosystem? Where does the energy go? And then why is it rare to have more than 4 trophic levels? And you may or may not know what trophic levels refer to right now, but we'll talk about that in a little bit more detail as well. So, how does energy move through an ecosystem? Well, you probably learned this in elementary school, and that's through a food chain. Okay, what is a food chain? It shows the flow of energy in an ecosystem. So here on the right, you have the plants eaten by carnivores. Okay, or excuse me, if it's a species eating a plant, it's not a carnivore, it's an herbivore. Herbivores mean they only eat plants. Carnivores eat meat. The arrows that you see here in this food chain show which way the energy actually moves. The ultimate or top of this food chain is going to be this hawk as it eats the snake. Don't worry about this part, as it was just something we would have done if we were live in class with our notes. Now, when you have some groups of interconnected food chains, we get what's known as a food web. Think of food web this way. So the grasshopper is not only going to eat this plant, it's going to eat other plants. The mouse is not only going to eat this grasshopper, it's going to eat other animals. So the food web is going to show the multiple species that eat other plants or other animals. So for example, if I were to say, look at the algae, what all eats the algae? Well, we have the Daphnia, we have the sedge, we have the tadpole. And then if you look at the sedge, it is eaten by other animals. The geese, the dragonfly, the moth, the ant, etc. And then the moth is eaten by the frog. Okay, is eaten. The frog also eats the dragonfly. So this just shows the interconnected multiple food chains that are out there. So trophic levels, what are we talking about? Trophic levels are now steps in the food chain. So here is a trophic level. The grasshopper is a trophic level. The mouse is a trophic level. Snake and hawk, all trophic levels. Okay, the names of these trophic levels are listed here on the right-hand side. So all plants, really the start of that food chain, are going to be known as primary producers. Producer has to be the first step. Okay, and then whatever eats that producer or that plant is known as the primary consumer. And then secondary, tertiary, quaternary, etc. I want you to think about and contemplate right now, and we'll talk about this, is why do you think there is not as many of the fourth level consumers as there would be the first level consumers? Why do you think that's the case? Well, we're going to talk about that a little bit. So again, these trophic levels show and describe how energy flows in the ecosystem. So what happens with this energy? Now, as you are at the bottom of the food chain, these producers have obviously the 100% of the energy. When they are eaten, they only send 10% of their total energy to the next level. 90% of that energy is lost as heat. Okay, so all of these animals give off heat, okay, and only send on 10% of the possible energy as they go to the next level. So the plant only sends 10% to the grasshopper. Now, of that total energy that was there, the grasshopper is only going to send 10% of that amount of energy to the mouse. And then same to the snake, and then the same to the hawks. Okay? Only 10% of the energy is available. 90% is lost as heat. Yeah, remember that. That's important. Okay, so think about this in terms of numbers. Okay, which one has the most? Well, we obviously know that producers, the plants, there's more producers and plants, and then there's more primary consumers, and then there's more. There's more plants or producers. There's less primary consumers than when compared to the plants, and then there's less of the secondary consumers when compared to the primary consumers, and then less to the next level. Why is that the case? Because there's not as much energy that can be passed on, so it can't sustain the same amount of animals. Okay, so why is it rare then to have more than 4 trophic levels? Because there's no energy at the top. Okay, there's a lot more of these plants than there are of hawks. Why? Because there's not as much energy to sustain. There's going to be less grasshoppers than total numbers of plants because of the amount of energy that's available. Less mice than number of grasshoppers. Less snakes than number of mice. Again, why? Because of the amount of energy that is available. There's less number of organisms as you go up each level. Here's another example. Think of it, energy, usually measured in what's known as joules. Okay, so if you have 10,000 joules in this primary producer, it's only going to send 1,000 of those joules to the next level. Where does the other go? The other percentage go? It is lost as heat. Then if you go from the grasshoppers to the mice, okay, of that 1,000, only 100 is used as energy. Then from the mice to the snake, only 10 joules. And then as you get to the hawks, only 1. That's why there's just no energy to sustain a lot of hawks. Okay, so pyramid of biomass. Again, what is biomass? We're talking about again, we talked about all of that, of the species that are around. So if we were to weigh all of these species, then the biomass is going to be much larger. So if we have a ton of these primary producers, and if we compare that as each level goes, okay, we're able to then sustain more animals at each level. But if we were to cut this in half, we'd have to cut the next level in half, the next level, and so on and so forth. Okay? At the trophic level, as the trophic level increases the biomass and number of individuals, each trophic level decreases. So why can't there be hawks? Because as we said, and I've said many times now, there's not enough energy. So how does energy move? Through a food chain. Where does the energy go? Well, 90% is lost as heat, 10% moves on. And why is it rare to have more than 4 trophic levels? There's just not enough energy to get passed on. Okay, this is another good slide, ending slide, for you to look at kind of the main ideas of this. You have just a couple activities to complete. The sheet that we were given to you yesterday over energy flow review, and then there's a crossword puzzle that goes along with today, just as kind of to review, and we will talk about succession in the next class. So have an outstanding day, and let me know what questions you have. If you need anything else, I'd be happy to help you, and we'll talk to you guys later.